So now we take the example over here. So we are using this example to explain how we're going to use the formulas to get the approximations for the numerical derivative, especially for the first derivative over here, this one. So this is where I want to get the first derivative values over here. And the last one we're going to find, so which one is the best approximations. So of course we can find this actually later. So you have your fx, you want to find the derivative value, meaning that this is your x equals to 2. So we take for the first one, the 2-point forward difference formulas over here, and this is how I calculate the values over already calculate the values. So these values and this value actually is come from the formula fx here. So what you need to do is just substitute this the x value, let's say your x equals to 2, you substitute into the functions and you get answers. The same thing for this one, for this answer, just substitute the x equals to 2.2 into your fx functions, and this is already given in your questions. And because of that, because we want to find the our f prime 2, so mean that this is my x and this is my x plus h. And take a look on the formula, and this is our formula for the 2-point forward difference. So mean that this one is my value for fx plus h, and this is my fx values. And what I need to do is I just substitute the corresponding values inside the formula with the h, because this is the h with the step size 0.2, so that's why this is 0.2, and simplify, I get the answer. So okay, the same thing goes for the next one is the 2-point backwards formula. It's just the same thing. First of all, you try to get the value first. Try to get what the value for 1.8 and the value for 2.0. And once you get this one, you just substitute, because you want to find the f prime 2.0. That means you're using this formula. This is the 2.0, the value functions. So you're going to substitute later this one, the value is this, as well as as well as 1.8 is this value. So once you already have, you just get the answer. So the same thing for the center difference. And the center difference formula is given by this one. And of course, this is something slightly different. This is divided by 2h. So what you need to do, you get the value for the functions 2.2 and also for the 1.x. So the 1.8, you get the function values. And next, you're just going to simplify and you get the answer. Okay. So the next one, also the same thing for the 3-point forwards difference. So you just get the value for the forwards difference. You get that this is let's say this is your x, this is your x plus h, and this is the x plus 2h. Yeah. So once you have this one, you just recall back what is the formula over here, and then next you're going to substitute the values one by one. So meaning that this one you are replaced by the value of this, and then this one you're going to replace by this one, and the last one f2 which is just replaced by this one, and you simplify, you will get the answer like this one. And this is the answer for the numerical approximation using 3-point forward difference formula. So the same thing, you go for the 3 points over here. So this is just the same thing. And then the last one, you have the 5 points. So because of that, we have the 5 formula here. So what do you think actually? Which one is the most accurate answer that we have? Yeah. So which one is the best actually? Maybe it's a second 2-point, 3-point, or 5 points. So which one is the best one? So if let's say you have this before that the answer that we get from the A until the E or F here, actually all answer is approximations. You want to know the best one, so you need to get the exact solution first for the derivative when the x equals to 0. So what that means? So we need to do the differentiation for the fx here. We get the first order derivative. So once we have this, we're going to substitute the values and we get the derivative. And once we get the derivative formulas, we're going to substitute inside this table, and this is what table I summarized all the answer that we have on the previous calculation, and this is the exact solution that we have here. So what I need to do is I just calculate the absolute error using exact minus the numerical results. I have this one, and when we go through this one by one, we found out the best approximation is the 5-point centered different formulas. We give the result, the smaller error over here,